Today we are going to talk about AWS RDS, that is the relational database service that Amazon provides, and we will be seeing what is RDS, what are RDS instances, how to secure them, how to make them highly available, and what you can do with snapshots or within RDS and all those things. And if time permits, we will see Dynamo DB as well today. So that's me. This is the topic of interest for the day. RDS, Dynamo DB, and a little bit introduction to Elastic Cache, when to use them, the building blocks that make up these services, and finally we will have an in-depth demo about RDS and Dynamo DB as well. And remember, some of these demos will require the MySQL commands to be executed. I have written an article to help us with that. So we should be able to take help of that article and have the commands in ready-made place. So we should be able to copy paste it or make small modifications and use it in our use case. So let us go ahead and see each topic one by one. The first one that we are going to see is the Relational Database Service, or RDS it is called. It is part of the database group of services offered by Amazon, and it is a highly managed service provided by Amazon. And it is the relational database service provided by Amazon. When I say relational, it is rows and columns, and there is some relationship between all the records, or all the records form a similar structure. Say, for example, a table of students in a particular classroom. So the relationship is all of them are students, and all of them might be from the same class, and they might be from a particular school, or some kind of relationship will be there. And each student will have their name, age, sex, marks, and then their preferences, hobbies, preferred subjects, and so on and so forth. So that is what a relational database will look like, and that's kind of a database can be run on the cloud without installing, without managing, without configuring, because all of those activities are done by Amazon. You just go ahead and start consuming it. The one interesting thing about RDS, in my opinion, is you have plenty of engines available. Here is the different features of RDS, but if you move your focus on the right hand side, you will find that RDS is available as a MySQL engine, that is a database which runs a MySQL, or you can run a Postgres SQL engine, or you can run Microsoft SQL, or MariaDB, even Oracle as well. And Amazon has introduced its own flavor of database engine, which is called as Amazon Aurora, which is compatible with MySQL and one more database. I forgot about that, but it is binary compatible with MySQL. What it means is any database which is stored in MySQL at the moment, let us say it is stored here, and you want to migrate to Aurora, you don't have any problems because it is binary compatible, and all the data will move smoothly or imported without any hiccups into Aurora DB. So that is what a binary compatibility means. Coming to the feature set of what Amazon offers in RDS, it is very simple to use. I would definitely agree with that when compared to what the databases in on-premise setups look like. All you have to do is choose your subnets where your database needs to be, customize the locale settings, your time settings, or in other words, the parameters that define your database, which you might be doing or might not be doing depending upon what kind of parameters you need, and then choose the type of engine, and then you select the database type. Say I want a DB2 T2 micro, DB T2 micro, or a DB say M4 or R4 large, that which means that you're choosing a certain amount of CPU and RAM, and click on create. The RDS is going to do all the processing and give you an endpoint which you can start communicating in your applications with. Cost effective, of course, absolutely, because you are not installing the R database, you are not configuring the database, you are not setting up the high availability, automatic patching, all of those things are taken care. So comparatively, it is very cost effective in my opinion. And when it comes to security, RDS can have databases encrypted using your own keys, because KMS service provides you both these options, your keys or Amazon's own keys, or any other keys that you might be interested in creating and using it for database purpose or corporate purpose or compliance reasons. And it uses EBS volumes underneath. You are not going to choose the EBS volumes, but you will be able to choose your provisioned IOPS level. So you can choose my database needs 20,000 IOPS or 40,000 IOPS or 5,000 IOPS. You can go and dial up the performance. So that way you can clearly predict what is going to be your performance for your database when you choose a provisioned IOPS type of RDS service. And once you do that, it scales to your demand. Say, for example, if you are not having enough CPU and memory capacity, all you have to do is just change your instance type for your database and you'll have a higher instance. And if you need more I/O performance, go ahead and increase your provisioned IOPS. Then you can have more network capacity also. So this way you can scale up to demand, or you can come back also anytime, and literally your database grows vertically up or down as your demand grows. And nowadays, Amazon introduced some other concepts called as database clusters, and also they are coming up with Aurora DB has this benefit, not RDS itself. Aurora has this global database, that is multi-master database. In multiple regions, you will have masters and you will have global read writes without a conflict possible. So it's a tricky thing to set up multiple masters in databases, but that is what the modern world is moving in. You will have a master database in America, you will have one in Europe, one in Asia, and another one in Australia, and all of them will have the data completely synchronized, and people can read and write from it any point in time. So multi-master databases becoming more and more common nowadays. Compatibility and maintenance, I don't have to even talk about it, because almost all the services in Amazon is very nicely integrated. Say, for example, in this case, RDS is integrated with VPC, so that you can have security of your VPC layer, saying you want a security group defined for database alone, you wanted separate subnets defined for your database, or let us say you want to connect your database through particular IP addresses only using NACLs. That way it is more secure, and then it is integrated with your KMS service so that it can access your keys up, in or out very smoothly, and it is integrated with CloudWatch so that you can monitor your databases with the different metrics that CloudWatch offers to you. And this integration leads to the next part, because it is a lot of things are integrated and automated. You don't have to do a lot of administrative stuff. For example, Amazon takes care of the minor version upgrades of your database. Amazon can take snapshots of your database every day regularly without you doing much work. You just have to put in the timestamp saying, I want my database to take a backup at every day at 12 o'clock, and I want this backup to run for half an hour. And if it is not completed in half an hour, it is going to automatically stop the backup, and you can continue with your production activities. And you can also decide when your minor upgrades are going to happen, whether it is going to be on Sunday night or Monday night, and how much time window you want to take your database offline for your upgrade activities. So you just give your time window and the date, Amazon will do that for you. So these are all the different features. Let us go ahead and see what is an RDS instance itself. When you're talking about a database, you need to provision an underlying instance which will provide the compute and memory capacity of the database. So it is the building block or basic building block of your RDS instance. And there can be multiple databases. I mean, when you say I'm creating an RDS instance, each instance can have multiple database on top of it. For example, I will have a students database, and I will have a staff database. I will have a database for the school itself, or I will have another database for parents and teachers, all those other metadata. So all these things collectively will be used by, let us say, a school for running their operations. So one instance will have multiple databases in short. And all of those databases will run in their own isolated environment. Remember the parameters I spoke about. For example, if you are running in a Spanish region, you would want to have characters which will accept Spanish names, because they will have that accent in their names, and when you write it in English, you will have those special characters, and you would want to have them stored in a proper format. You might not be able to do that if you're storing the data in English format. Another use case will be if you're a transaction based e-commerce portal. Let us say you want to record the transactions to a millisecond level or per second level, and if you are in a globally distributed way, you want to note whether the transaction happened at CET time or UTC time or an Indian Standard Time, so that you can say your a payment happened on so and so date, and that was before the cutoff or after the cutoff of the offer. Or you can say if it's a credit card company, you will say that the billing was done after that or before that. So your timestamp, in other words, becomes very, very important, and you need to decide what is the timestamp or what is the date time format your database is using. All those things becomes critical. So all of those things make up your instance. Now that you set up your instance, how do I have my security of my instance? There are multiple ways listed here. Just let us go over them. First is the VPCs, which brings in your security group, subnets, NACLs, all of those security along with your VPC. Then you can configure IAM policies to see who can access your RDS itself, who can manage your RDS instance, who can stop them, who can stop it, start it, and who can take a snapshot, who can restore it, who can copy it to another region. Through IAM policies, you can do that. Then you have an SSL connection also. You can securely connect your database using your SSL, which can be configured with your connection managers, and encryption through KMS service, so that your database and your snapshots are all encrypted when the data is at rest. Then if your data is at a moving level, or if you are talking about a database is particular to Oracle DB or Microsoft, they have their own encryption standard called as a TDE. That encryption standard is also supported in RDS. Finally, RDS comes with some other security features. I mean, every database engine comes with some other security features of its own, because every database will have an let us say, for example, MySQL, it will have an admin user, and then there will be other users to connect to the database and make some modifications, and there are certain ways to tie down the permissions of this user itself. So you can use those features as well and tie down your database so it is more secure in the cloud. So finally, we set up your instance, we set up the security part of it. Now we are going to the management part of it, or operation side of it. How do I take backups? There are two different ways. One is the automatic backup, another one is the manual backup. We saw automatic. All you have to do is choose the time and date and time, and it is by default enabled for you. You will have to manually disable it, or you have to uncheck that feature. And the database retains those snapshots for a default retention period of 35 days. If you want, you can go ahead and customize it, even put it as 0 or 1 or whatever retention days you would like to. When it comes to manual snapshots, you can go ahead and take it anytime. It is always initiated by the user, and it is never deleted by Amazon at all. Whereas in the automatic backups, after 35 days, the oldest backup will be deleted. When it comes to manual snapshot, nobody will delete it. It will still reside in your account, and you will have to manually go ahead and clean up your manual snapshots. So that is another interesting thing. If you take a lot of manual snapshots, then you need to go ahead and configure your cleanup activities as part of your process. So what can I do with my snapshots now? Say my database is, the production master database is in the US region, and my developers are in some other country, and I need to give them a snapshot of my database so that they can do some development activities. What can I do with my RDS snapshots? First thing is, if your developer is sitting in India and your production is in US, you need to give them a snapshot of your database so that the development activities happen on live data and not some old data. So most probably what you will do is, you will take a snapshot, you will move it to in a Mumbai region and create another RDS instance using that snapshot. So this way your developers will have lowest latency, and they might also have the latest data also to develop the code or the functionality. That is one use case. The next use case is disaster recovery. You wouldn't want to keep your master data in the same location for reasons of disasters. If a disaster strikes, you would want to keep it away so that you can bring up your functionality or your web application in another region. And finally, compliance reasons are also there, which will mandate that you need to move the data to a different region, which is geographically separated. So these are the different reasons for having a cross-region snapshots. Of course, that doesn't mean that you cannot take a snapshot in the same region. That is also possible. But once you've done that, what can you do with that is the question. And these are the three use cases commonly cross-region snapshots are used for. So these are the two things: database parameter groups and DB option groups. These are the two things Amazon gives you to customize your database. When I talk about the parameter groups, this comes from your database engine itself. The parameter group for RDS MySQL will be different. The parameter group for Oracle will be different, and the parameter group for Microsoft will be different. But you don't have to remember all of them. Amazon gives you a default customized parameter group for all these engines. But if you want to further customize it, for example, the date and timestamp that I spoke about, or the locale character, saying if you want to use more than ASCII characters, say ISO, ABC, that particular format of font that you want to support, you can go ahead and customize that. Apart from that, there are some 20, 30 or more than that. You can go ahead and customize any of them depending upon your application use case. So this is at the database level. At the administrative level, you have the DB option groups. For example, DB option groups gives you the flexibility of choosing when do I want my databases to be taken backup. Say all your production databases needs to go offline at Sunday for doing a backup, whereas your dev and test can have a backup, say anytime during the day and the evening. So something like that you can configure in your options group. So they appear on your database configuration details as the screenshot shows on the right hand side. So how do I set up my database now? Let us think about and imagine a simple web application. You have the load balancer at the front, which is accepting traffic, and you have two application servers running in EC2, and they are load balanced with the ELB. And those two application servers are in turn connecting to your master database now. And this master database is taking snapshots to your S3 bucket. Everything is fantastic, but in my opinion, the only problem with this kind of architecture is there is only one database instance and there is a single point of failure here, and there is no multi-AC or a standby server available. If something has to happen to your master instance, you are going to lose your database connectivity, and as a whole your application will lose its functionality. So once again, when we talk about high availability, we come to the same concept of multi-AC deployments, and RDS also allows you to do that. So what typically when you choose a multi-AC option happens is Amazon will automatically create a replica in the other availability zone that you choose. Say wherever you have created the subnets, it will automatically go ahead and choose one of those subnets and create an replica copy. And that replica will be synchronously replicated. Say you write to one data here and you just go ahead and query the same data in the other database. It will be you will be able to read that data immediately because each AZs have a millisecond latency, and if you remember the regions we talk about in the earlier sessions, the latency between two AZs are really less, and you can literally query them almost instantaneously. We saw that in the EFS sessions as well. You can write it in one AZ, pick it up in another AZ, and modify it in the other AZ. So go ahead and use multi-AZ deployments for your production without failures. Even if somebody argues against it, it is your responsibility to go ahead and talk to them saying the failover happens automatically. Say one AZ is gone offline, the failover from master to the replica happens automatically. And remember, this replica is not something that you can use it from your application end to improve your performance, because there is two instances. Why should I connect only to the one? That is not a way. I mean, the Amazon doesn't allow you to do that. It has the replica, but the replica will be promoted to a master only when the master is offline or having some health issues because of underlying hardware or any software above that. So that is what a multi-AZ deployment. And how does it look like in an architecture way? This is how it is. The same architecture, we just added a couple of application servers, and we also have a master and slave now, and both of them are synchronously replicating, and snapshots are going to your S3. So this is how your architecture should look like for production databases. So we saw what is an RDS itself, what is a relational database, what are the services offered by Amazon in RDS. But there is another type of service or another type of database engine which is getting more and more popular in the world, and this is called as the NoSQL engine. There are a lot of open source technologies which tackle this problem. The common one is called as the MongoDB, and the Facebook version of a NoSQL database or columnar database, actually speaking, is a Cassandra DB. And there are some other databases like CouchDB, but Amazon variant is called as Dynamo DB. So whenever somebody says Dynamo DB, it is a NoSQL database which has a predictable and scalable performance. Why I am saying predictable and scalable is NoSQL database runs or Dynamo DB runs on SSD disks, and SSD disks always have a consistent performance. And if you set that I want to have this many write units of performance and this many read units of performance, so you will be consistently getting those kind of performances. And it is scalable because you are not storing in a relational database like a tables and columns. Each of the data will be stored in a format called as collections, and the collections might be a group of flat files. The best use cases, think of you storing your vacation pictures and images. You will have a name of the vacation name. Say I went in April for so and so place, and all the photos under that. And then you will go to another vacation after 6 months, and you just put a top level directory name and all the images beneath that. So nobody will know how many images will come inside those pictures. And think of now uploading all this into Facebook, into groups or collections. So they have to store it somewhere, and this is the use case DynamoDB solves. Because every person will create a different group collections, and every person will add different types of files into it. I will collect my music files, you will collect your images, somebody will collect their video files, and somebody will put some CSV files. So what is going inside the collections is absolutely flexible, and what is the size of those collections, again it is flexible, and what is the metadata about those collections, you can decide how you want. This is at the database level, but when you want to store it, DynamoDB allows you to have this flexibility of any type of file format. It doesn't say I need to have binary format only, I need to have CSV format, I will have to have ASCII text. These are some of the restrictions that your RDS will bring into picture. You cannot directly store your binary objects. You will need to create columns, and each of those columns you need to decide whether it is string characters or integers or binary columns. But in DynamoDB, you just create a collection, go ahead and do that. That is one of the broader level differences between an RDS and a DynamoDB. Again, this is highly scalable because Amazon automatically creates a replica for you, and you don't have to do anything. There is no concept of multi-AZ deployments here. Once you create a DynamoDB, and automatically Amazon ensures that you have the necessary replica in your S3 kind of storage, and you don't have to worry about the failures anymore. And literally the service takes minutes to get up and running. Very simple, and I wouldn't say exactly cost effective, but considering the performance it gives and considering the capabilities it has, it is one of the competitive cost in the market. Because I've seen DynamoDB cost overshadowing all the other costs sometimes, but the performance it gives for mobile applications or front ends which need a lot of I/O, and each of those I/O is like in millions, then DynamoDB is a fantastic use case for you. So in short, there is a summary of all the things that we just now spoke about. When you're talking about an SQL database, the data itself is stored in rows and columns, whereas in NoSQL, it is a key and value. In our case, let us say it is a vacation name, and the value is your all the image names that is stored there. And the schema is fixed, that is what type of format of data that I need to store is fixed. And when it comes to NoSQL, there is dynamic. You can have a different schema, I can have a different kind of a storage. And querying, that is the interesting part. You need to use the SQL standard querying format for RDS, whereas when it comes to NoSQL, you can run through your collections using the JSON querying format. Like you will get a JSON, and within that JSON, you can use a Java or Python code to traverse how to find out which collection is where and how much data is there. Scalability is always vertical in RDS. If you remember, I spoke about increasing the CPU and memory by choosing the instance type, and also changing the performance of the disks by using the provisioned IOPS. So these are the only way or you can scale your SQL instance. Whereas when it comes to NoSQL, it is horizontally scaling because each of them are stored in a separate collection. If my first disk is running out of space, all I have to do is add another disk, and I'll continue the collection and add it to my index saying this collection is in this place. So depending upon your use case, you will choose SQL or NoSQL. There is no straightforward answers. But when you're starting out, the Amazon says if you are building a new application, you have some 100 users or 1,000 users, most probably SQL will be meeting your demand. But when you're talking about a globally distributed use cases with a lot of million of IOs and small IO activities like gaming or Twitter feed processing or real-time management of your data, then NoSQL makes sense, but that is also after X number of users. When you're starting out, SQL makes a fantastic use case for most of the scenarios. Again, use case level description between both those databases. When you're talking about application type, then existing databases or business process centric databases you can do, but NoSQL when you're talking only about web scale or large number of reads and writes. Why the reason I keep saying about gaming is if there is a particular game in the market and say there is a 10,000 users are playing it, each of them will be at a different level in that game, and each of them will have a different high scores, and at the game overall will have some high scores. So constantly this game will be updating to the server to find out where you are. Say Candy Crush for this example, it will quickly show who are your friends and then what is their best score, and within the friends who have got the best score and what level they are in, and you can interact with them to get the lives, or you can buy some products from the app itself. So all of this activity is constantly going to the server and coming back. So large web scale applications and small read writes, NoSQL is best. And the next thing that you will choose on deciding is relational data models. What type of data model that you are using, whether it is complex queries or join queries. This is quite interesting part. You cannot do something like this in Dynamo DB. Running a join query in Dynamo DB is very difficult, and its performance, however, it is in SSD. One second. So complex queries cannot be done in DynamoDB. So if your database requires, or if your application requires you to run complex queries, then you need to go with SQL only. That is the best performance application for this use case. Then if you need scaling by clustering, partitioning, and sharding, then you can choose RDS. But if you want a seamless integration and on-demand scaling, then you need to choose with DynamoDB. Finally, your quality of service. If your performance depends on your querying, say once again going back to here, and how often you can optimize your querying and reliability and durability, then you will choose this. But if you want all of this to be done by somebody for you, that is Amazon or some service provider, then you will have to choose with DynamoDB, because the performance optimization and the snapshotting, replicas, high availability, everything is taken care by Amazon and NoSQL. So you can go ahead and choose that. So depending upon your use case, there is no one single straightforward answer like ABC. You go ahead and choose this. So here is how you choose your performance of your DynamoDB. In short, what happens is there is one read capacity and then the write capacity. So if you want to choose what type of read or write, you need to choose that with Amazon. In this case, read capacity is identified as 4 KB, and if your write capacity is identified as 1 KB. So you go to and talk to your application teams and see how much read they are going to do and how much concurrent reads they are going to do, and overall in a typical day how much they will do. Then you go ahead and divide that number. Say I will do 10,000 reads, and each of those read will be, let us say, 8 KB. Then what you're going to do is you are going to provision with 20,000 read units, because they said that 10,000 and it is 8 KB of data they are reading. So per unit, Amazon provides only 4 KB of capacity. So if you want 20,000 that amount, you need to go ahead and set up 20,000 units. Likewise, you go ahead and choose what is your write capacity unit, and per unit capacity is only as large as 1 KB only. Even if you do, say, for example, 512 bytes, Amazon will count it as 1 KB of write unit. So anything lesser than this or closer to this, you will choose only 1 KB as your write capacity unit. And based on this, your performance will be allocated and the disks will be optimized. The underlying disks will be optimized for this kind of performance. So this is a simple data model. Let us try to see how a collection will look like in reality. Although when you go to a console, you will be asked to, the terminology will be used as a database only, but underlying this is what happens. Here is an example of a data model for a music album. And let us say each music album, each row that you see, there is a single music album, and each album will have an artist, a song title, and then you will have album title, year, genre, and all those fields. And you can notice that all the albums are not having all the fields. Some album is having year, some album is having genre, and other album is not having it. So this is how a DynamoDB data model will look like in reality. And each of them will called as items. So the entire thing is a collection, and inside that collection you will have multiple items, and in this case each item is a music album. And to optimize the querying, what Amazon says is you go ahead and create a partition key or some kind of a unique value that will identify each collection so that you can easily retrieve it. In this case, the artist name is chosen as the partition key so that you can identify it easily. Then you can go ahead and do one more thing also. You can create a sort key, because each artist will have multiple songs, and you can go ahead and sort it and pick them based on that. Then finally, once you do this, you can go ahead and query saying that I want that in the table music, I want to list me all the albums written by this particular artist and sort them by song title. So I will get a smaller subset of data, and again I will write another query finding out saying song title should be so and so, and give me that value only. So that is how you use your table sort key and partition key to identify a particular item in your collection. This is think of it as a quick snapshot or a primer into how NoSQL querying will work like. Then to improve the performance, Amazon has something like you have a local secondary index, and then the global secondary index is also there. In addition to your partition key, you can go ahead and identify the albums based on your album title also. So it allows you to query it based on some more parameters. So instead of having, let us say, A Rahman has 10,000 songs, just give me all the titles starting with A and then all the song titles starting with B, and combination of this will be lesser, so I can have lesser data to process through in my application. So let's move forward. A simple application architecture for Dynamo DB will look like this, and you can see here the interestingly the front ends are all shown as different devices, mobile, tablet, and computer, and they enter your database through load balancer, which is ideal in my opinion. Always have a load balancer in front of your application servers, and which will cascade it to your EC2 fleet of servers, or you might have a web app server. On the backend level, you will have your Dynamo DB. So that is how you need to set up an three-tier architecture. This is not exactly three-tier, two-tier, I would say. Web app servers, that is why I said. But this is how you need to do. You always have to have a load balancer and application servers in auto-scaling mode, and Dynamo DB, which can also have auto-scaling today. And then you can go ahead and set up your two tiers like this, and security groups and VPCs built on top of them. So let us go ahead and see some considerations of when to choose what. First and foremost, there is no one size database fits everybody. You need to decide what you are going to use for your application, and what I'm going for doing for my application will not suit you, even if you are doing the same application also, because my user base might be different, your user base might be different, and my users might be coming from one region. Their latency requirement will be different, and your latency will be. So one size doesn't fit all. So after setting that golden rule in the beginning, so what are the other dimensions that I can choose when when other dimensions that I should carefully look for and choosing a database? Data format, what type of data I'm going to store, whether it is CSV, music files, video files, HTML files, or binary data, ASCII data. Choose all that, and then see what is the size of the data. Is all of the data is going to be 1 KB, 1 MB, 1 gigabyte, or 10 terabytes? What is the size of your data that you are going to store? How often you are going to query your data, whether you are querying all of the data at the same time, or some of your data quite often, or all the data will be infrequently accessed. So data access speed, what is your read operations, write operations? So based on this, then you will have to decide your database, whether it is NoSQL. If it is NoSQL, then go ahead with DynamoDB, and if it is SQL, then you need to decide which engine that you need to run. So when I say engine, MySQL, Oracle, MS SQL, Postgres, anything. So that's how these are two important services Amazon offers when you're talking about a database itself. So next thing we are going to do is going to the dashboard and start setting up these services and see how we can interact with them. So let us go to our dashboard, to RDS service. And in my opinion, the first thing that you need to start is creating an subnet group, and then creating a parameter group, and then going and starting your instance itself, because you need to decide what parameters your database is going to have before you have it. Although you can go ahead and modify the parameters later, but that will require a reboot to get applied. So first thing, subnet groups, next your parameter groups, and then go ahead and start your instances. So let us do the first thing, subnet groups. And as of now, there are no subnet groups, so let us go ahead and create one. I'm just going to say RDS demo subnet group. And which VPC? This is the QVPC, because I'm going to put my application clients in my QVPC only, so I'm going to choose this one VPC. And which all the subnets I want both my subnets 1A and 1B. In 1A, I will probably have to go to my VPC to find out which is my private subnet here, because the description is not appearing. So let me open my VPC dashboard. So I'm in my VPC dashboard section. Under the subnets, what I'm going to do is I'm just going to say Q-AZ So it just filters it based on that. So what I'm going to first thing I'm going to do is go and find out what is the private for AZ1. That is, usually when I say AZ1, I name it for 1A availability zone, and my subnet in this case is 1CAB. This is the subnet for me. So I'm just going to go back to my RDS console and choose 1CAB. This is the one. So for that AZ1, I've chosen that, and then I'm going to click on add subnet. It will appear in the bottom. So I'm going to do the same thing for AZB also. And let us go ahead and find out what is our subnet ID by changing this one to EC2. And it says that my subnet is D60. Let us go ahead and pick the same thing, D60. Okay, great, and click on add subnet, and let us go ahead and create our subnet group now. That is how simple you go ahead and create your subnet group. So next thing is parameter groups, and these are the default parameter groups that already Amazon has. I'm just going to say I'm going to create another parameter group, and I wanted this parameter group for MySQL because I'm going to start an RDS instance in MySQL and 5.7. So I'm just going to use the same thing. I'm going to call this as custom param group for MySQL 5.7. So go ahead and click on create. Okay, must contain only digits, letters, digits, or hyphens. Okay, the dot was the problem. I removed the dot, so that worked. So options groups, you can go ahead and customize it, but nothing much is going to do. Let us say so we are going to do this for MySQL. Go ahead and choose MySQL. What is the major version? 5.7. I'm just going to choose that option as well. So we have done all these customizations before starting our instance. So let us go ahead and start our instance itself. Before that, let me take you to the dashboard. As of now, there is nothing there. If I go to my instances also, there's absolutely no instances running. Let us go ahead and create our first RDS instance. You can see here, launch DB instance. Click on that. This is where your choices are coming into the picture. The different Amazon offered database engines, Aurora, MySQL, MariaDB. You can go ahead and choose anything, anytime. The licenses are managed by Amazon itself automatically. It is not easy to import your on-premise licenses to these cloud licenses. It is recommended that you go ahead and discuss with your vendor to see whether you can import it. Otherwise, go ahead and choose the default ones and done with it. And remember, some of them are charged here. For example, Aurora DB is not a free for trial purpose. That is for the free tier account. At the bottom, you will have enable only the free tier. If I choose this, you can see automatically the Aurora DB is disabled. I cannot choose that option anymore. Since the option was selected already, the tick was there. Let me go ahead and choose that now. I cannot choose Aurora DB, but if I choose that, I will be having an additional pricing that will be applicable. So you see here, there's a friendly warning message that comes up. So for the demo purpose, go ahead and choose MySQL. And if you want to know the difference between this and this, you can see here, this supports a database size of 16 terabytes and then this much memory. And there is a limit on the number of read replicas also. Whereas if I go ahead and choose Aurora DB, you can see here it will go all the way up to 16 terabytes and it has 15 read replicas with sub 10-second lag. So it's really a high performance database that Amazon has created in Aurora DB. And if your client says that I want RDS only and I want really high performance, you can blindly suggest Aurora DB as one of the options to consider. For demo purpose, let us go ahead and stick with MySQL. Click on next. And here is the parameters that we are going to choose with. So let us go ahead and choose 5.7. What is the latest version? 5.19. Let us go ahead and choose that. And automatically your license gets updated as well. And then if you go ahead and uncheck this, you will see that multi-AZ deployment gets enabled. If you say that I want only free tier options, under free tier you will not be able to create a multi-tier application. So first let us set a database in only one tier, and let us go ahead and change the multi-tier later. And here is the database engine, and let me unfreeze this. And if I unfreeze that, I get all this bigger size database engines, database memory and CPU capacity available. For free tier, you are allowed only a TB T2 micro only. So that is the only option available. So let us go ahead and keep this unchecked, but let us choose the options carefully. And by default, SSD disks, you can want to improve your performance, go ahead and choose provision IOPS, and you can go ahead and choose how much you want. So, and if you choose the general purpose, 20 GB is the minimum. You cannot go lesser than that. Earlier it was 5 GB, now it has gone up to all the way to 20 GB. That is the storage that your database needs. So here is the other things that you will need. These are all custom parameters. You can go ahead and choose whichever field you want. So I'm going to call my DB instance as DB instance 01, and master user is equal to DB user, and then the password DB user pass. I just want to be careful so that I don't lose it. Typically this is what I'm going to put. I'm just going to keep it somewhere so that I know that. So here's the VPC part. Let me go ahead and choose the QVPC, and you can see here by default the subnet group, it automatically picks up the one that we created. If it is not there, it will automatically create a subnet group and give a drop down with that option only. Since we done that, we don't have to worry about it, and it's asking whether you want the RDS to be publicly available. No, we can make sure that your RDS is not publicly available, and no EC2 instances outside of the VPC will be able to connect. Yes, that is what I want. I don't want public access to my VPC. And in this case, let us make sure that my master, that is our single instance, is going to be in 1A. Then we'll go ahead and enable multi-AZ and see whether it is starting up in 1B also. So then which security groups I want, I'm going to select it manually, and see here this default already chosen. Let me remove that, and I'm going to choose the private security group. And remember, I need to ensure my private security group is allowing traffic from my public, because my client is going to sit in public. So we'll go ahead and edit it in the VPC in a short while after finishing the remaining configurations. So because we need this port number, we'll use that. So what is going to be my database name? And I'm going to call my database name as students, STUDENT, students DB. Okay, let us remember that, because we will use this database to connect in a short while. And my DB params group is 5.6. That is interesting. Why it is not reflecting? There is probably a version confliction, because for some reason some of the options that I chose is not allowing me to choose the 5.7 DB parameter group and options group that we created. We'll check that later. But anyway, you will discuss this usually with your the version number, especially discuss with your application team on what version of database they need and choose that. Let us copy the snapshots, and let us do not need an IAM as of now for administering the database itself. And for the DB instance class, that is T2 micro, encryption is not supported. If you go ahead and start a bigger instance, you will be able to choose the encryption as well. And finally, how often your database needs to be done backup. So 7 days, 35 days, whatever you want, you can go ahead and choose that. And I have no preference of my database. Go ahead and choose that. If you have preference, go ahead and select it and set your time. And remember, these times are in UTC. So if you are in CET, PET, or PST, or whatever time zone you are in, convert it and update it in UTC. Monitoring, if you want more information about what is happening in your database, then go ahead and choose enhanced monitoring. And what is your frequency, 1 minute level or sub 1 minute level? Let us choose default of setting of 1 minute. That should be fine. And do you want your export your logs? Yes, let us say I want to export all my logs and send it to CloudWatch. Finally, maintenance part of it, the important part, whether you want your minor versions to upgrade or not, and if you want a preference of time window when you want to do it. Let us say I want to do it every Sunday at let us say 00 hours and 30 minutes. All I have to do is something like this, and I want to happen the upgrade itself to get completed in 1 hour. So I've chosen this option. Go ahead and launch DB instance. Okay, backup window, did we choose a time here? Okay, I'm just going to say the backup is going to start at after the upgrade at 2. So that should not be a problem now. Click on launch instance. So it has taken all the parameters and it is going to launch my instance. Let us go ahead and see the details that we have done so far. And remember, we need to update our VPC also. While the database is getting booted up, we go ahead and do that. Meanwhile, this is my instance, and DB instance 01 is what I created. And if I scroll down, all the parameters, all the fields that we have chosen, everything is listed out here. And once the database comes online, this field will be updated with the domain name through which we will be able to access our RDS instance itself. So for now, it is still creating. If you just look at this option, it says that DB instance status is getting created. Getting creating. So let us leave that as it is and let us just go and see. This is the configuration of the database itself, the network part, the instance details, and the monitoring part of it. They just segregated in a nice 4 columns so that you can focus on which option that you want to modify or anything. So I am interested in this security group. I'm just going to click on that so that we can configure it to enable port 3306 access. Let us close this notification. So as of now, my inbound rules allow port 80 and port 22 only. I'm just going to edit it and say RDS or not RDS, MySQL. So automatically it chooses my port here, and then I'm going to say my web security group. So my web security group, or in other words called as public security group, and click on save. And if I take you back to my EC2 dashboard, remember I have an RDS client set up in the same VPC and I have put it in the public security group. So we should be able to connect to our database from this server as well. So let us wait for our RDS to come online. It's going to take some time. Let us wait for that. Here you can see here my database has been set up and it is still not yet available because it is doing the initial backup. And if I go to my snapshots, and I should be seeing a snapshot being created here, and then there is a status is creation in progress and about 1%. So any RDS instance that you create for the first time, it is going to set up the database and it will do an automatic backup almost instantaneously after the database creation is completed. So this is where the snapshot section, but let us go back to instances and see it has completed its boot up cycle. And you can see here there's another interesting thing I'm going to show you. The connections is as of now 0, and if we use our terminal server and then we go and connect it, this session will be incrementing by 1, and we'll slowly see how it increments when I start a secondary server as a replica and what happens after that. You can see here my endpoint is ready, and once the backup is completed its process, then we should be able to connect to it and write to it. In this article, we have most of the steps or most of the commands that we are going to run for the remaining part of the demo. This is the steps written to how to connect to an EC2 instance, and this is the syntax for that. Let us go ahead and plug in our domain, the endpoint, and then our master user or password here, -h, and the domain, the endpoint I copied from my dashboard. So -p, that is the port number, and then we are going to use the username. If you remember, I gave the username as a DB user. Let me go ahead and confirm that is the username that I've used earlier. Yeah. And then the -p is for the password part of it. So I'm just going to copy this and go to my EC2 server, which is connected through PuTTY. Here I'm going to just paste it. And if everything is working fine, I should be given a password prompt. So my security group and my RDS, everything has come online. So I'm just going to put in the password now. And you see here, I'm connected to the server and it says, gives the MySQL prompt. If security group or my RDS has not come online, I will not get this prompt. So the next is I'm going to ask the RDS database to show me all your databases. So the command for that is something like show databases, and it shows me the students DB that we created when we are setting up the RDS itself. So I'm going to say use students DB, and I'm just going to say show tables. So show me all the tables that is inside your database now. So the database is students, and show me the tables. As of now, there are no tables. So the first thing we are going to do is set up some tables in my RDS. Copy this command from your article, which is going to create our table with the student name. The table name is going to be students, ID, name, and city. So just copy this back to our terminal, paste it, and press enter. Now it says that query is okay and it is executed. So if I go back and execute my show tables, and it will show that there is one table called as students. And as of now, there is nothing in my tables. If I say select star from students, it will say there are 0 queries. So as of now, there are no students in my data in my tables. So let us go ahead and insert some students now. For that as well, I have written the article which will be inserting some students. These are the values. Let us go ahead and insert the first 4 records into our table now. So let us go ahead and paste them. And if I go ahead and execute, show me all the students from all the records from my students table, it is going to show me the 4 records that we just now inserted. And it says that there is a person called Anil from Singapore, and there is a person called Reddy from Hyderabad, and there is a person called Vale from Chennai. So there are 4 records we have updated, and that is how you interact from your application to your RDS itself. We interacted through creating a table, we inserted some records. If you want to go ahead and retrieve it, I just retrieved all the records from my table by using the select star command. You can go ahead and retrieve individual records also, say for. So here I'm going to execute this record, which picks up my student ID where the last name is Reddy. So I should be getting these 2 records, or actually I should be getting only 2 and 3. Let us go ahead and execute it and see what happens. So you see here student ID is 2 and 3. Likewise, you can go ahead and change this value, say give me the city, and then from where we can also do that. So all you have to do is something like this, and I should be getting the city as Hyderabad. So now that is how you interact with your database. So coming back to AWS RDS, let us see how we can go ahead and create a snapshot, and which is a point in time backup of your data. So when I say point in time, there are 4 records, and all these 4 records will be taken, should be taken as a backup now. Let us go ahead and do that. We are back in the RDS console, and I'm just going to refresh my screen to see all the values are taken into effect and databases come online. And you can see here the number of connections has come up to 1 because there is a 1 client that is interacting with my database now. So let us go ahead and ensure that we have selected our instance of choice and click on actions, and you have an option saying take snapshot. And remember, what the action that we are doing now is a manual snapshot. So I'm just going to call it as a manual snap with 4 records. Take snapshot. I just gave it 4 snapshots because what we are going to do is after the snapshot is triggered, we are going to insert some records, and we will create a database from this snapshot also and see how many records are there in this snapshot. So that is one thing. What we have done so far is just trigger a manual snapshot, and you can see here it is in the creating stage now, and it is going to complete its processing in its own time. Let us not wait for that. Let us go back to instances. And in case if you want to change any parameter or anything for this database itself, you can use this instance option and go ahead and change it. Say for example, I want to create a read replica, that is a master where I can read and write data to it. But there are certain queries where only the read operations happens, and I want to from my application send those queries to a different instance which will handle only read to improve my application performance. I can do that as well. So all I have to do is click on create read replica, and it is going to ask me some questions like for example, what is the DB parameter group and availability zone. In this case, I'm going to choose ACP and make sure that I'm not in public. And what is the instance class? Again, I'm going to say this is going to be in T2 micro only. I don't want a multi-AZ one. And I'm going to go ahead and choose the other settings here as well. General purpose, everything is fine, default. So I'm just going to say DB instance identifier. So DB inst 01 read replica. That is what I'm going to create. And copy the snags and snapshots. Yes. I'm going to leave everything else as default. And remember, it is going to pick some of the other default values from my instance itself. You can see here, my database is still not at available state. It is doing its background processing. It's not finished. So It's not allowing me to create a read replica. We'll have to wait for some more time. My database has come online now, and you can see here the connection level is at 1. Once my read replica comes online, we should be able to see this connection level jump to 2. Let us go ahead and see, go to our previous dashboard and see we can complete the process of creating a read replica for our instance. Just let me scroll down and click on create. If everything else is fine, we should be able to trigger the request to create a read replica. So we have successfully done that, and let me find out. There will be one section where it will list out all the read replicas, all the other instances connecting to this database. Here you can find out that the replication status, as of now in the replication status, there is just one. And if you remember, we chose availability zone 1B for my replication read replica instance. It will appear here once that request has been completed. You can see here it is modifying my DB instance. Earlier it was saying backing up. Now it is saying modifying, because it is creating a synchronous connection between my master database and my read replica here. So that is the state changes. And let me scroll down to the replication segment. And here we go. There is the master here and my DB instance read replica here. And this is in availability zone 1A, and this one is in the availability zone 1B, and you can see the role of each player. This is a master, and I cannot edit or do anything to this instance itself. Here you can see the summary view of my instances. There is one master and there is one read replica, and my read replica is getting created, and after my read replica is created, there will be a snapshot for this as well, and then this will also come into available state, and my connection will change into 2. And of course, this read instance will also get its own endpoint. Once the process of setting it up completes, you will get its own endpoint. We should be able to connect it from our server and see whether we can read data from it. And we'll also try to write to it and see what happens after that. Okay, finally, both my instances have come online. And the interesting part is, if you see the connections, my master has 2 connections now. That is because my read replica is also talking to my master. So if I connect to my read replica now using its endpoint, and the same username password should work for my read replica as well. Here is the endpoint for my read replica. Just copy this. So we have got the syntax right. Let us go ahead and connect to our read replica. Let us go ahead and put the password. So connected to it, let us go ahead and say use students DB, and we have changed to students DB. Select select star from students. I should be able to see all the 4 records that we created. So what I'm going to do now is I'm just going to try and insert a record from this, because this is a read replica. I'm going to do a write operation or insert another record now. So I'm just going back to the article, pick up the last record, and let us go ahead and try and insert it. Paste it here and press enter. And you can see here this server is only in a read-only mode, and it cannot accept any statement, cannot execute the statement. Whereas if I go to my master server and just go ahead and execute, I selected the wrong one. Let's just go ahead and copy the statement again. So my record is executed. If I say select star from students, I should have 5 records now, and you can see here there is a Martian record entry that has been done, whereas read replica is almost a synchronous copy. So let me just execute it, and you can see here the data is replicated already in my read replica copy, and this data is there. But remember, we took a snapshot when there were only 4 records. So let us go ahead and restore the snapshot and see how many records are there in that snapshot. Here I am in my snapshot section, and you can see here this is a manual snapshot that we created, and I'm just going to restore this snapshot now. Under snapshot actions, I'm going to say restore, and we are just going to select all the other parameters and leave the ones which I've already seen as default itself. Let us not choose multi-AZ. Let us go ahead and choose the DB2 micro, fine with me, and then DB from snap, and QVPC is fine. The subnet group that we set up is fine. I'm just going to say 1A and leave this as default. We don't have to choose any of them. Just go ahead and is there a security group option somewhere mentioned here? No. Okay. Let us see what security group it goes into. If it is not going into the private security group, we'll go ahead and ensure that this instance has a private security group assigned to it. So as usual, it is going to go into the creating state, then it will take a backup, and then it will go ahead and give you an endpoint through which we can connect to it. So this is one way of restoring from your snapshot. And sometimes what happens is you will need to promote your read replica to your master also. Say that I want to create a completely different database from my original server. What you would ideally to do is create a read replica first, and all the data will be copied between the read and the master and the read replica. Once you have all the latest data, just stop read write activity on your master and go to your read replica, and then what you have option is promote read replica. So when I promote this, what happens is this will become an individual database of its own. It will no longer have a synchronous connection between that. So all you have to do is just go ahead and choose the server and update it as a promote read replica. And it is going to ask you the other questions for any master server. What is the database? What is the retention period? Just click on continue. And it is saying that it will not have connectivity and all those things. Do you really want to do that? Are you sure you want to promote? In other words, yes, I want to promote. Go ahead and do that. So it will say modifying state here, and these connections will again come back to 1 after some time. So you can see here my activity of promoting my master has already taken into effect. This is my master server instance. You can see here that is the original server that we started, and this is my read replica which is already being promoted to my master, and the connections have already reduced from 2 to 1, and the snapshot that we restored is also getting created. So all the three databases are individual databases now. There is no connection between any of them, but this guy will have only 4 records. This snapshot guy will have 4 records, and this read replica guy will have 5 records. This will also have 5 records. My read replica is on. It is completing its backup operations. Meanwhile, let us go ahead and see the endpoint has come online, so we should be able to interact with our server now. We are in our read replica server. I'm just going to execute a command to say select start from students, and there are 5 records. What I'm going to do now is I'm just going to try and insert another record because it is promoted. It should work. I'm just going to edit the student field here to say 006 and say Martian 1, and let us go ahead and see select start from students. And did I not edit it properly? Okay, I did not edit it to 6. So at least a Martian 1 edit has updated properly. So now you can see here, earlier when I tried to insert a record, it was giving me an error saying this is running with the -- read only option. Now I promoted that server, and I can happily insert records into the server because this is completely separate from my initial configuration of read replica. So that is how you promote your read replica into a master. We created another database from our snapshot. Let us go ahead and connect to that one as well. So I want to connect to this database now. That is a DB from Snap, and it is an available state. Good. We can go ahead and connect and see how many records are there. Here is my endpoint. Let me connect it properly. So, and then put in the port 3306 and then the username. And then the password. I think my port is not working. My security group is having some problems. Let me just go ahead and confirm that. You can notice here, I earlier spoke about this because when you're restoring a snapshot, it doesn't exactly allow me to choose the security group that I want it to be in. It is in the default security group, and it has its own rules. So we have not exactly allowed a 3306. In short, what happened was my security group was in the default value, so it is why not allowing me to connect. We have changed it to the private security group where we have ensured the port is allowed and it is secure so that it can connect only from a web server. And we are trying to apply. It gives you a choice whether you want to apply it in the next maintenance window or apply it immediately. In this case, I want to connect it immediately because there is no way that I'm going to wait until next Sunday just because my port is not working, my applications are going to be offline. So apply immediately, click on modify instance, and it is going to take that change and it is going to apply that change to the server now. You can see here my security group has changed. I'm just going to go ahead and see the rules now. What it says private security group, good. I should be able to go ahead and attempt another connection to the server now. So you can see here it is a can't connect because there were some problems. So just let us go ahead and attempt another connection. DB. So there we go. Once we change our security group, straight away we got connected now. I'm just going to use the students DB and say no, that is also wrong. Show databases and use students DB and select star from students. We should be able to see only 4 records now. If you remember, we inserted 5 records in my master, and then in my read replica also we created another 2 records, but none of them will reflect from the snapshot we created because this snapshot was created when there were only 4 records in my data. So in the real world, database keeps on changing. That is why you need to take incremental backups every single day, so that when the point when there is a disaster or a failure and you want to restore, you will have the latest information to restore all the data. So take incremental backups and constantly recycle them so that you don't incur a lot of charges for snapshots also. Here we are in our Dynamo DB dashboard. All we have to the first step is creating the table, and it is going to ask me what is the name of the table. Once again, the article that I have written takes care of Dynamo DB as well, and I have given the default values that you can fit in there, not default, customized values, because the rest of the commands take into these values into account. So if you change them here, make sure that you can go ahead and change them in the commands as well. Say for example, you are creating a new table. I'm just going to call this as AWS students. I'm just going to put in the same thing in my Dynamo DB as well, that is as my table name. So what is my primary key? Most probably student ID or student name is what I'm going to use as the primary key. So in this case, I'm going to use it as student's ID, and I'm going to choose the type as string. So in case a student ID needs to be a number, you can go ahead and choose that. But in this use case, I'm going to use it as string, and I don't want another sort key because my database is very simple. It's just a students. I don't need sort keys and all those things. So here's the interesting part. If you want to improve your performance more, and if you want a better read write than the default of 5 reads and 5 writes, if you remember, each read gives you about 4 KB of data, and each write will give you about 1 KB of data. So by default, I'm given 5 read. That means that literally 20 KB of read write per second, and then 5 KB of write per second for me. If I want to change this, just uncheck this field, and then you can go ahead and edit my capacity index here. And then let us say I want to have a minimum capacity of something like 100 units, and I just go ahead and modify it here. That is on the read level. On the write level, usually write will be lesser than your read. So you will talk to your application team and see what is the ratio of read write. Then you can go ahead and choose it. And of course, the cost is also given to you. And if you want to calculate more, you can go ahead and choose that calculator and see what is going to be a cost impact for choosing that type of performance. For learning purpose, definitely default settings is more than enough for you. Just go ahead and select that, click create. And it is going to take these parameters and it is going to set up your collections now. So once your table or collections is set up, on the right hand side, you will have all the metrics about your collections. So it is setting it up. So my table has been set up. That is the amount of time it took to set up my Dynamo DB table at all. Literally super fast in my opinion. So you can see here the items. As of now, there is nothing in my tables. So this field is completely empty, or there is no items. And when we go ahead and insert, we will go ahead and see how the items list up here. These are all the management items, metrics, alarms, how much capacity I have provisioned. Once again, after setting up your database, you can come here and go ahead and change it anytime also. And you can, as if you remember, I said auto scaling is available in Dynamo DB also. So you can go ahead and configure certain percentages. So this way you can automatically grow your database and reduce them also. That is why you have a maximum, minimum, and then as a maximum. And what is the percentage when you want to trigger these thresholds to automatically increase or decrease? So that is also possible. And remember, I have created only one index, that is student ID. I don't have any other global secondary indexes created. If it is there, then it will come up here. And do I want a workflow created? Say my Lambda triggers some operations in my Dynamo DB, or when an S3 upload triggers a Dynamo DB update. So you can configure your triggers to do that. Again, it's an application configuration. It's not you go ahead and set it up for some performance improvement or anything. Dynamo DB itself is very simple. Create a table and you will deal with items only. So how do I insert items? For that, Dynamo DB, in this case, I'm going to write it as a JSON items or some JSON files. So this is how the file will look like. I'm going to create these 4 files now, and then I'm going to use the AWS CLI command to put these items into my Dynamo DB itself. So let us go ahead and have a server which will have AWS CLI access, which can interact with the Dynamo DB. Okay, I've booted. I'm just going to ensure that I have root level access. Okay, good. I should be able to use this server to insert records. Let me clean all these files. So we have inserted 4 records after creating our files. So using the article, we just use the Dynamo DB input item. Let us go to our Dynamo DB itself and see what is there in the items now. So as of now, it looks like there's nothing there. Let me go ahead and refresh the screen. And you can see here all the 4 records that we inserted from our terminal is there. And as I said, to repeat, you will never use a terminal 99% of the times unless you're troubleshooting it. You will not go ahead and insert it through that way. You will be doing this from your application. So for example, let us say I want to retrieve a record. So what I will do is I'll use a get item action. So here is the command for getting an item. So in this case, I'm going to retrieve the student number 3. Just copy this, and then I'm just going to put it here. And it is going to retrieve the item and return the JSON object. So you can see here it retrieved the item and it says that student is 3, and then I find that this value is wrong and this value is empty, so I need to correct it. So I'm going to insert a new record and update this record so that these values are corrected. So let us go ahead and create a collection which is having the proper data. I'm just going to enter that. So we have created a new file called student3, and then we are going to use the put item to update that record itself. So if I'm just going to select this and put it here, and I'm not going to retrieve it this time in my console. I'm going to go to my AWS dashboard. I'm going to select mic here. You can see the 881 is updated here. If I click on item number 3, it is going to give me all the details here. Of course, I can come here and edit it, but this is easy when you are having 3 records, 10 records. But when you have millions of records, you cannot literally use the console to make changes. And of course, you can also go ahead and delete a record from here, but literally you won't do that from here. And delete item also you can do by using the Dynamo DB-delete action. If I go to my metrics now, there will be some small spikes, hopefully, from all the put items and get items that we did. You can see the default capacity that is provisioned for me is mentioned here as 5, and then I'm literally using nothing here. So far, I'm not just literally pushed it up so that I've consumed all the 5 units. If you remember, this is for read means that is 20 KB of capacity is provisioned for me, and then this is about I'm consuming less than 1 KB, that is 1 unit. And write capacity is also 5, and write is like 5 KBs for me, and I'm using a tiny fraction of it. You can see here there's like literally a small tiny line there. So that is how you set up Dynamo DB in your account. If you have any problem with that or any doubts with that, let me know. I'll try to help you with that.